Hello, everyone, and welcome back to Perceive 2021. Please give a warm welcome to our distinguished guest, Praneet. And Praneet is the Senior Solution Engineer from Clarifai, and he will be speaking about visual predictive maintenance. Welcome to our stage.
Thank you. So as Yushin mentioned, I'll be talking about Clarifai Visual Predictive Maintenance, as we like to really abbreviate here as Clarifai VPMX. And really what it's about is understanding your equipment. You know, a lot of people can have various different equipment, from pipes to turbines, various equipment that's out in the real world under environmental stress. And there are many consequences to not knowing your equipment. Equipment of all types can suffer from degradation. There's a lot of corrosion, there's a lot of cracks. It's complex machinery. It's made up of many parts, and it's tough managing and tracking it all. And then human maintainers can make mistakes on this equipment. And of course, not maintaining your equipment and not knowing it could have a lot of costs. So your equipment is essential. The more time it's just not being used, that's a compounding cost. Safety is also crucial. So failure can be costly and disastrous, as we'll find with a few key examples. And then considerable time and money is spent by human maintainers. The repairs are repetitive and reactive. So there's a wide variety of equipment. It's not just like toolboxes or just engines, right? Like we commonly think of like aircraft. Engines are a complex set of parts that go through extreme environmental conditions, but it's also the structure of the aircraft, like the wings, the actual vertical and horizontal stabilizers. Turbines, think of like wind turbines. They're expensive, they're crucial to infrastructure, and they're really hard to replace. Wind turbines are huge. There's a lot of transportation cost, and they're just expensive in general. And then finally, pipelines. You've got a vast infrastructure stretching vast areas of land that can cause major damage if not maintained properly, right? You can have oil spills, you can have leaking, and again, they're crucial infrastructure. So here's where I want to present an idea. What if you could understand your equipment with AI, right? As we've seen, it's crucial infrastructure, it's crucial equipment, there's a huge cost to it. And then finally, you have those human maintainers. They can't just stare at something time and time again. So this is where you could leverage automation and precision with finely tuned computer vision models, right? We can actually present an idea where computer vision can serve as better than human performance and just give you all that automation and precision. And as more data comes in, you can improve those models. You could also create a shared data environment. A big problem with just getting feedback from equipment, it's all in siloed data sets. And when you introduce a visual element, you can actually just use these models to synthesize that data and actually put it in a shared data lake. And then deploying those models in multiple environments enhances that detection and collaboration ability. We can use computer vision models that are interoperable and function with various sort of sensory domains. So what does that do for you, right? It reduces downtime of that equipment. As we discussed, equipment that just sits around or is broken, it costs you money and you have to fix it. And then the cost, again, mentioning the degradation and the cost of repair and replacement. If you understand understand your equipment better and sooner, you can reduce this cost. And then finally, risk, right? Equipment has to be safe for operators and consumers. And when you find those cracks or corrosion, you get to reduce that risk. That is a fundamental property of all of this. So let's talk about a real world use case with aircraft. Aircraft, as I mentioned, are very complex machine. There's the structure, there's all the moving parts, the engine, and it's in the air where you have a lot of extreme environmental conditions. So here are some challenges around just aircraft, and it's very similar to just everything. It's a reactive maintenance process for corrosion, leaks, cracks, peeling, etc. The unit cost, think of like a 737 or a fighter jet, it's very high. It's millions of dollars. And sometimes cracks and corrosion, if it's a very just supersonic jet, high speed territory, that can down a jet. And then the actual inspection process is very manual. You've got thousands of fasteners, panels, it's variable accuracy. The humans are just exhausted by this. So here's why AI comes in. You have those highly accurate, consistent models and workflows to rapidly accelerate this detection of defects. The human operators, relieved as they are, can quickly verify and improve those models without having the burden of just manually inspecting everything. And then as this data set grows, you can use that model history to examine over time how something is changing, right? The precision is there. And as the data is structured, you can compare it temporally. So why would you care, right? You'd greatly reduce depot time for anyone that, works in just an aircraft fleet, works with an aircraft fleet. There's critical aircraft, and some aircraft can take 2 years to clear. So you greatly reduce that. You greatly reduce maintenance cost and human labor cost. Aircraft parts are very complex and expensive. And when it comes to the supply chain, especially right now, that is just even greater. You can keep track of potential issues and repairs as they evolve over time. So creating these accurate predictions and projections is essential for this equipment. And that all relies on accurate predictions by those models and being beyond human level accuracy and precision. And then finally, you greatly reduce the risk of flight operators and maintainers. You can prevent catastrophic damage or loss of life. As I mentioned, a crack can down a jet, well, especially if there's a person in it, that gets even worse. So how are we doing this? Let's actually examine how we actually do it with, Clarifai, right? So in this example, we actually integrated with a smartphone app where we can ingest this imagery data. So you have actual people in the field taking pictures of panels, taking pictures of actual fastener areas, right? So the Clarifai platform actually has a flexible gRPC API, and it can ingest this high resolution imagery and it gets indexed in the Clarifai platform. There's also a structured database that they have where it keeps track of different, let's say, jet codes, different aircraft, and they want to catalog, how each fastener is corroding within each panel. So that's the structured database component. Then there's also an RPA component where they want to send alerts and thresholds to notify maintainers. So this end-to-end example with Clarifai being a critical component of this, actually adding structure to that unstructured data, that's typically the hardest part in all of this. So here's an example of Clarifai models actually detecting fasteners and detecting corrosion in fasteners on a side panel. If you look at the above examples right there, you can kind of see the confidence levels of, okay, this one has this much corrosion, this much has that much corrosion. And then a bottom example on another commercial airliner is just paint peeling, right? So right out of the box, we've built Clarifai models that have extremely high accuracy in detecting these different types of just anomalies on aircraft. Then we get to the training and inference component. So first, we want to actually train detectors. We want to find all those fasteners. Then once the fasteners are found, we want to take those cropped areas to reduce the region where we want to classify very, very minute corrosion. So that's where we do the fastener corrosion ranking. So we need ample data. Ample data is labeled in Clarifai to train those detectors and classifiers. And then we build that multi-model workflow to run the detection, reduce the region, and then classify very, very accurately. So this is where inference comes in. Once those models are trained, the operator can actually capture the entire surface area and label each component, let's say side panel or underside. That component metadata and timestamp we can actually use as part of the inferencing. And then as it's coming into the multi-model workflow, we can actually detect anomalies, corrosion, leaking, whatever model workflows we built. In this example, just fasteners, and we can actually score this in time. And as the structured data is sent for scoring, we can compare that across time to see, okay, is corrosion getting worse on, let's say, a side panel or a underside? And finally, I want to present this as, visual predictive maintenance. You can be very creative with it, right? I've mentioned industrial equipment, right? Power lines, or sorry, pipelines, aircraft, turbines. But you could easily do this for buildings, right? There's a lot of cases where buildings are cracking, poorly maintained. You can use computer vision with people in the field, actually in construction, looking at different cracked components and letting computer vision do the work. You can use this for vehicle parts, right? Tires and brakes. A lot of damage is done because people forget to check the brakes or tires or engines, right? This component in the inside of the vehicle. And that's a lot of cost for the consumer, but a lot of risk for them as well. You can use this for power lines. There's a lot of degrading power lines everywhere. Think of, in the state of California, you have a lot of degrading power lines that have caused wildfires. That's a huge cost. And then finally, roads and rail, right? Just transportation infrastructure right now is just degrading, and we want to improve that, right? Computer vision can certainly improve that. And that's all I had for today. Thank you.
Great. Thank you so much, Praneeth. This is always a fascinating topic because actually earlier during the presentation, I also gave a talk on anomaly detections. I think anomaly detection and predictive maintenance are really popular topic when it comes to manufacturing. So it's a pleasure to learn about visual predictive maintenance. A big round of applause to our virtual audience. We'll see you at the next session. Thank you.
Thank you.